A very warm good afternoon to all of you. And I'm pleased to welcome all distinguished panel members here. And I hope we are going to have a very unique and interesting discussion around emission technologies and what kind of challenges we as industry as well as the kind of different stakeholders are facing. To begin with, I would like to introduce the panel members, starting from just my right-hand side, Amit Bhatt. Amit is the Managing Director of IICCT India. He has around 2 decades of experience in transportation, urban development, and management. Amit is also one of the faculty member at School of Planning and Architecture in New Delhi. Please join me welcoming Mr. Bhatt. Next in line, we have Mr. Balachandra Deshmukh. He is Associate Vice President and Head Industrial of Highway Application Engineering, Kirloskar Motors. He has approximately 25 years of experience working around all kind of engines, starting from, you name it, the kind of engines which are there in the market, starting from agriculture to construction equipment and others. And he has experience in terms of both business side as well as the technical side. And then next in line, we have Mr. Neelkant Marathe. I think Mr. Marathe doesn't need any introduction. We all are aware about his stay with ARAI around 22 years. And the kind of, and I think he has witnessed all kind of the transformation the organization has gone under his able leadership. Currently, he is Executive Director of Emission Control Manufacturing Association, ECMA. This represents world's leading manufacturer of emission control equipment for automotive and non-road engines in India. The topic of discussion which we have been given here is the choice and challenges, what we are going to face in terms of the emission technologies. We are going to touch upon them, the emission control technologies, as well as the newer technologies, the newer ultra powertrains, including electrification and the bioethanol part of it. So, this reminds me the story when India was moving from BS4 to BS6. And I had an interesting discussion with Mr. Marathe a few years back about it. And he pointed out why not skip BS5. So there is no need of gradual movement from BS4 to BS5 to BS6, which was highlighted in Automotive Fuel Vision Policy 2025. That time, 2 challenges were there, right? One was the upgradation of fuel, so heavy investment requirements in the refineries. And the second one was in terms of upgradation of OEMs, the technology upgradation, which definitely results into the cost repercussions because of the additional components like ECU, high pressure component, HPCR, WTC, cooled EGR, and other kind of components. So my first question to Mr. Balachandra is that, Balachandra, you are dealing with several kind of engines, right? So what are the challenges OEMs are currently facing in terms of upgrading them? Because I think fuel is already available, right? So that challenge is not there. But in terms of what kind of, there are additional components which has to be adopted by OEMs, as well as engine has to be tuned, fine-tuned, and so many other kind of technological upgradations has to be done. So can you please highlight what kind of challenges we as an OEM are facing at this point in time?
Yeah, this is a very important question. I remember that when last time I met here in the CVF, that was a time for the BS4 or CV4. And it was in the discussion that time we were moving from the CV3 to the CV4, so mechanical engine to the electronic engine, and top up to that the EGT, that is a exhaust gas treatment and everything. And it was very well assumed in the context that now almost all technology is available in the commercial vehicle from the passenger car side, and off-highway is following. Let me tell you that the technology availability and the challenges from the application related to the usage, to the environment, to the duty cycle, to the duty factor are totally different. So having the technology availability doesn't guarantee you that it's a very easy path and there are no challenges. And when we migrated from the CEV3 to the CEV4, and now we are migrating from CEV4 to the CEV5, there are definitely challenges. It's the challenges for the engine manufacturer also, and challenges for the my partners who are the equipment manufacturer also. Because in the off-highway, the life is totally different. What we compare as a off-highway, as a passenger car or the commercial vehicle is totally different. So here the main challenges is particularly from the one engine to the different application with the different duty cycle, with the different load factor, with the different environment and the operations. And then calibrating the engine to the level of legislation and calibrating the engine to the level of performance. That is very, very important and very, very important challenge from the engine manufacturer. That is first. Second challenge, particularly from the equipment point of view, the end user, the practices followed at the ground level, when you are migrating from the mechanical engine to the electronic engine and top up to that to the EZT and almost to the high-end technology, now in CV5, I can say that might be my understanding, that in CV5, whatever the technology is going to be put on the diesel engine, I said that diesel engine said, thanks. We are reaching to the end of the technology from the diesel engine point of view. You see the EZT, you see the electronic fuel injection system, upgradation may happen, but technology point of view, we are reaching to the that point. So these are the very important challenges. One is from the practice point of view. Another is for considering the different equipments and then calibrating or optimizing the performance and legislation so that it can meet the performance also and the reliability also. I think that these are the two important challenges. So having a technology availability, that is a one thing, but the challenges for the off-highway are totally different, and these are the very, very two important challenges. Still, we are continuing. My OEMs, they are also working on that. We as an engine manufacturer also working on that, because just for the CEV4, it's only 2 years happened. Now the CEV5 comes. I think that these challenges still continue for some years to get stabilized.
Thank you very much. I think you brought a very important point, which is in terms of the timeline, right? So if you look at the timelines, starting from 2020, TREM 4 and CV4 timelines has been shifted several times, and now we are into the implementation phase. But if you look at the TREM 5, which is going to be the bigger challenge, as you highlighted, the timeline is very, very short, right? So any kind of regulation, whenever it is there, these are very, so industry always tries to push the timeline, right? But don't you think this time it's very logical and it is going to be almost very, very difficult to meet within 1 year of timeline upgradation from TREM 4 to 5 or CEV 4 to 5? What's your opinion about that?
Yeah, as an individual, definitely it's quite challenging. As just now I said, technology availability doesn't mean that everything is there. It's quite challenging, not from the engine manufacturer, but from the equipment manufacturer also. Yes, I agree it's challenging, but once the legislation is defined and what is in our hand, rather than to following it and meeting the deadlines, and we are already started work long back, and I can say that as a Kirloskar Engines Limited, we are having already engines which are for the CV5, and we are started supplying to our OEMs as a proto so that they can continue their field trials, and both the team can have a learning and the further incorporation for the further improvement point of view. But definitely, it's a challenge.
Thank you very much. I will move to Mr. Marathe, and Mr. Marathe, your opinion about the choice and challenges what OEMs have at this point in time, and also the companies like Kirloskar Motors. What are their challenges? And when we talk about the after-treatment technology, do you think the suppliers are available in India and they are ready to collaborate, even not only for the just supply part of it, but also for the calibration as well as the overall testing of the vehicle, so that it doesn't also compromises on the entire performance of the vehicle?
Thank you, Mr. Pritesh. Good afternoon. Dr. Deshmukh has already given the preamble of what are the challenges there and in what way the way forward is. In my opinion, between the on-highway sector and the off-highway sector, one biggest difference is that for off-highway vehicle, if you look into the emission table, there are different power categories. Particularly, if you look into the present tier 5 table, all power categories are included, right from smallest to more than 560 kilowatt also. And for every power category, there is a segmentation, and for every power category, the emission limits are different. So this brings one challenge to the OEM, because every power category having different emission table will need different technology. Ultimately, technology means cost, technology means investment. Therefore, for different power segment, different technology, a lot of work is involved. And when it comes to bringing up the product to the satisfaction of the legislation, because ultimately everything is done to pass the legislation first and to meet the requirement of the customer as well. And you will notice that legislation and customers' expectations, they do not go hand in hand. Customer need fuel economy, legislation want emission to control, and there is a trade-off between the two. Therefore, a lot of work is involved to maintain the fuel economy at the same time, achieve the emissions. And while doing that, every OEM, Dr. Deshmukh is working very deeply into the development, he will agree, and he will probably must be doing like that. We'll have to first clean the engine as much as possible in the cylinders so that the emissions are as low as there. Then whatever is left out, and the gap is there between the emission table and emission coming out of the engine cylinder, has to be made by after treatment. Sometimes, in order to bring the balance between the fuel economy and after treatment, yes, there are different strategies. For example, if you want to achieve fuel economy at the same time meet the emission standards, people may look into the possibility of improving the cylinder combustion in such a way that it gives you best fuel economy, which will yield more NOx emissions. Because more you work on improving the combustion, there will be a situation where NOx is higher, and then you take benefit of technologies available in the after treatment like SCR or in-cylinder capability of EGR to maintain little bit of balance between the two. So these are how the challenges are met. So either you make the engine combustion to give more NOx and reduce it in the after treatment, or you make the combustion to give less NOx, where there will be penalty of the fuel economy, which will have the different after treatment to control particulates. So different technologies are there. The in-cylinder combustion development has also reached to its ultimate, as Dr. Deshmukh said, how much to take more from the diesel now. High pressure fuel injection is one of the thing which is being used extensively to improve the air fuel mixing, because that is one of the criteria to improve the combustion. Then everybody is trying to get more from the small, that is high specific power output, more from the small. That also brings a lot of pressure, because gas pressures will increase, that will increase the mechanical pressure, that will increase the temperature, that will increase the heat dissipation. Because of that, tolerances between the components are required to be optimized. That will create a lot of burden on the manufacturing. Because of heavy gas pressures generated in the combustion chamber, technology to bring different materials are also required to be brought in. That will have impact on the cost. So many things are interrelated. There is going to be different challenges. And when it comes to after treatment, there is a big difference between the off-road working style and highway vehicle working style. Normally, in highway vehicles, you have acceleration, deceleration, high-speed operations. But in off-roads, that is missing to a greater extent. Therefore, exhaust temperature will be always a criteria, which may not be achieved to achieve the best efficiency of any after-treatment device, because after-treatment devices work best when the temperatures are higher. And this grossly is a missing part for off-road sector. Therefore, development of after-treatment devices becomes more challenging. If you are adopting DPF, then how to regenerate that DPF at lower temperatures of exhaust, whether passive regeneration is good or active regeneration is good, both have got their own pluses and minuses. So a lot of things are required to be discussed and then found out which works best in the economics point of view. There are many, many such things which probably, if we keep on talking, time will be a
Yeah, Mr. Ram,
shortage.
thank you very much.
Thank you.
I think very uniquely you have put it across. One follow-up question to you. What I understood is that there is a trade-off between controlling the NOx and particulate matter, right? Whenever you are dealing with any technology. I was giving the automotive industry passenger car market example, and when the requirement was from switching from BS4 to BS6, this debate happened there also. Many of the companies, OEMs, actually gave away on this, and that is how they discontinued their diesel portfolio in India. But they had option of at least the petrol engines and then the other alternate powertrains. But here we don't have that option. So in that trade-off, if you control like NOx by putting additional components, if my understanding is correct, like EGR, then the PM goes up, right? Then you have to control that, and for controlling that, you need to go for the after treatment technology like SCR, LNT, whatever you choose. So in the off-highway segment, from you, I will ask this question, then I will take the perspective from Mr. Deshmukh around construction equipment. How do you foresee that OEMs are using which kind of roadmap, what roadmap they have in terms of controlling these two, the trade-off between NOx and particulate matter? What additional components they are putting for controlling NOx and PM?
Today we are in tier 4 world, and next year sometime in April there will be tier 5. Now these two tables were announced quite simultaneously. So I'm quite sure that OEM have started working for tier 5 along with tier 4. Most of the power segments for tier 4 table were having a relaxed NOx norms, therefore they were quite comfortable dealing with EGR to achieve, and some DOC, POC combination to achieve particulates. Therefore, tier 4 table, they were mostly dealing around EGR, DOC, POC, and they were able to match it. But when it comes to tier 5, where NOx and particulate, both are becoming stringent, plus particle number is also added. So this has compelled every engine manufacturer to go for after treatment. High class of after treatment, that means EGR alone will not be sufficient. So there can be a combination of EGR and SCR or SCR alone, depending upon every strategic coming from different OEMs. DPF is going to be must, because when particle number is added, according to my little knowledge, without DPF that cannot be achieved. And number is also reduced compared to tier 5. So both, that means DPF is mandatory, SCR alone or EGR plus SCR in that combination, depending upon what power segment you are dealing with, that will be necessary. So this is how the after treatment technology is going to be utilized, and I can only assure you that in India and globally also, all these after treatment devices with the best technologies available, and they can support engine manufacturers to achieve the targets.
Please allow me to ask one more follow-up question before I go to Mr. Deshmukh. So you said that in India, you talked about the different combination by which we can meet these norms, right, after treatment as well as. So you also mentioned that these technologies are available in India, which means the manufacturers are available in India, right? My question to you is that are these technologies kind of locally developed in India? Are they localized in India? And is there enough local content into it? Because when we talk about the national objectives of either putting stricter emission norms or moving towards any other kind of alternate powertrains, we talk about manufacturing import dependence, we talk about emission control, we talk about energy security. So in that national agenda, this manufacturing import dependence also is one of the very, very important part of it. So do you think these technologies are locally available in India, localized in India, or in future there is a high possibility that within 3 years or 5 years? So how do you see that?
These technologies are available in India. They're manufacturing plants in India. They're being used extensively by the on-road market, also by the off-road market. And wherever some more technical inputs are required, some companies, they have their principles globally available, and there will be certainly a path available for bringing the technology to meet the local requirements of the country. It's available. I can only tell you, technology is available, it's localized, plants are there in the country, and they can meet the requirement, both in number and quality.
Thank you very much. So, Mr. Deshmukh, if you can.
One thing
Please.
I would like to add, when it comes to after treatment and engine, they have to work together. And as engine is required to not only complete the prototype development, it requires a lot of field testing from robustness point of view. At the same time, after treatment devices also require a lot of field testing and robust testing to make sure that in the field it can serve the purpose of length of the engine life. Because that is very important. It should not so happen that engine is having longer life and after treatment devices has gone out of operation. It's not so.
Yeah. So thank you very much, Mr. Deshmukh. Your perspective around both the areas. One, the debate between the trade-off between NOx and PM, how the construction equipment manufacturer or the engine manufacturers are complying that. And second, your opinion about the localization of these after-treatment technologies or any additional components which are required to move from stage 4 to stage 5.
Yeah, I will start from the trade-off, particularly the particulate matter and the NOx. And for the diesel engine, they moves hand in hand. You have no choice. And with that, the best, with the performance, in the performance, particularly the fuel efficiency. And these two parameters and the fuel efficiency, I can't leave these two parameters aside and the fuel efficiency aside. So if we consider these three parameters, and because two are from the legislation point of view, and one is from the operational point of view. So they are the very, very important, and three of them having the, you will find everywhere the trade-off situation. And that is the biggest challenge from the optimization point of view. So everything, if you see that, particularly the IC engine, and particularly the compression ignition engine, nowadays I stopped saying the diesel engine, okay? That is a big myth we were carrying, and 5 years back, I took out that burden from my back. I am a CI person, I am a IC person, I am no more the any fuel person. That is the way. And I think that the standards also come that way. They are also fuel agnostic. They are also not talking about any fuel. Okay, coming back to that. So it's very important. It's only the combustion optimization and only the chemical factory. Chemical factory means the ECT, or beyond that also. So when we were working on the, particularly the off-highway engines, we have come out with the third parameter. Is there are anything beyond this also where, while these three parameters are in the trade-off, but we need to do the best of the best things. One is from the legislation point of view, and second is from the operational point of view. So there are other chances also how to resolve this trade-off. And I will tell you that the hardware like which we are using, the roller tappet. The roller tappet, usage of the roller tappet when such type of scenario comes, gives the advantage in terms of the fuel efficiency, particularly from the friction point of view. The hybrid governing, I don't know that how many people are using the hybrid governing. We have come out with the very novel concept called the hybrid governing, and all Kirloskar Engines Limited engines, either in the CEV4 or the CEV5, they are with the hybrid governing. And this become only possible because of the, as sir said, Marathe sir says, absolutely right, that when you understand that particular segment and off-highway and the commercial vehicle or passenger vehicle are totally different. You need to have that understanding about that applications and wide range of applications, and you need to see it on a lot of database, and then you will understand where is their operating zones, where is the fuel economy matters, where is the emission matters, and how to attack these points. These are the very, very important. And we come out with the hybrid governing. Hybrid governing is a very different concept. When we got the opportunity to use the electronic fuel injection system in the CAV4, because it is not possible in the mechanical fuel injection system, we come out with the hybrid governance. So such type of things allowing us to give the better benefits to the end user in terms of the fuel efficiency point of view. Whereas definitely the after treatment, as Marathe sir said, absolutely right, that there is a DPF, you have no choice. There is a SCR, you have no choice. There is a DOC, you have no choice. But take an example, the SCR. You are adding, they are the two flute now. And both are the consumables. Both are the consumables. One is the diesel, that is the fuel, and one is the DEF, that is also consumable. And most of the times in the off-highway, they are running almost 1:2 ratio. That is the consumption at both the level. So you can't have a freedom also that, okay, I can shoot up the NOx in the in-cylinder optimization and I can pour more urea. Ultimately, it is penalizing your pocket. So it's very, very important from the in-cylinder optimization also where I need to touch that sweet point. And where, okay, from there only, from the liquid, that is a DEF point of view, I can allow. Otherwise, once again, the OPEX at the end user level is totally different. So it is very, very important from the optimization point of view. Just I want to touch on the localization. Dr. Marathe already mentioned everything on that. I don't want to explain on that one. But yes, it's a true fact. If you are the local engine manufacturer, your local contents are almost reaching in, I can say that 70%, almost 70 to 75%. Still, we have the scope of 20-25% because many things comes from the outside, even though they get locally manufactured, but that comes from the outside. So almost 80% you can achieve that.
Thank you very much. So one last question to Mr. Marathe I have is, with the movement of these regulations, I think the engine lubricants requirements are going to be a very, very critical thing, right? And what changes you foresee in terms of lubricant requirements, your perspective around that?
Very tricky question, lubricant. Actually speaking, as Dr. Deshmukh said, fuel economy. The fuel economy means friction reduction. So it comes by lightweighting of the parts. It comes by improving the material contact, metal contact, where lubrication becomes one of the major requirement. So that is all happening now. Another problem with the lubricant is that the lubricant has got some pathways to go into the combustion chamber of the engine. It can be through valve stem seal, it can be through turbocharger seal, it can be through the gaps between the piston, ring, liner, skirt, so many things. And when that goes into the combustion chamber, it tries to burn, but it is heavier than diesel, heavier hydrocarbon, and adequate oxygen is not available to burn it efficiently. Therefore, it then converts into particulate. And that is the problem. Therefore, lubricating oil development is must. Plus, with more and more specific power increase, temperatures are increasing. That is also creating trouble. When it comes to particulate has got oil as one of the constituent, because particulate is not one thing. There are so many things into it. The lubricant oil related particulate part is also there. Lubricating oil also carries ash, and that is one of the major problem because of the when it comes to cleaning. when we are using DPF, for example, in tier 5 engines for most of the power ratings, and because there will be DPF which will be blocked as it is used, it requires regeneration, we need to do the cleaning periodically. That time, we need to look into the ash part of it. Now, removing the soot, there are ways and means to increase the temperature externally or by means of some passive regeneration. Soot can be removed, but when it comes to ash, ash cannot be burned easily. Therefore, passive regeneration becomes a critical topic. In that case, active regeneration is required, which will require extra fuel. That is a cost again. Extra fuel means extra fuel burning, extra hydrocarbon burning, more CO2 generation. Plus, different equipment will be required. You require injector, you require heater or burner or so many things. To find out the possibility between passive and active regeneration, if passive regeneration is cost effective, then we have to control ash content in the lubricating oil. Therefore, the future lubrication oil development which is going on is to control ash. The ashless lubricant oil will be the demand from the engine manufacturer, in my opinion.
Thank you very much for your perspective. Now, I'll move to Amit. Amit, the entire idea of emission standards and controlling the emission across the vehicle segments is that we want to reduce the pollution, right? Ultimately, that can be of different types. So, what is the role of different alternate technologies? Do you think the stricter emission norms are enough to control emissions in the off-highway segment as well as the construction equipment segment, or moving towards all other alternate options, which you can see a lot in the passenger mobility as of now? For example, in passenger cars, you can see the ethanol 20 blending, which is happening now. The fuel is available. And then we have diesel 5% blending also in the diesel. So India also is talking about the flex fuels, electrification, hydrogen. So in your opinion, is it like stricter emission norms are the way forward, or we need to focus more on alternate technologies? Because if we move parallel, cost pressure is always there. If you move from stage 4 to stage 5, definitely there are cost implications. And in this scenario, wherein the inflation is also going high, ultimately it impacts the final consumer. And at the same time, if you push for alternate powertrains also, then again, OEMs have to invest a lot in R&D, and they need to do the development. Again, investments has to be there. So in your opinion, what should be the optimal strategy, and which one is better?
Oh, thanks a lot. So I think there are two sides to this story. One is the emission. And again, we are looking at more from the public health side. The other is the fuel economy. And that is in a way also linked to emission, but more from the climate change perspective. And therefore, if you look at what European or North America is following, they are also looking at fuel economy standards or greenhouse gas standards or CO2 standards more from the climate change perspective. And the reason why it is important is that ultimately it all comes down together. So when we talk about having this investment and the return on equity, just maybe a month from now, you will see construction activities will be banned in Delhi NCR. And most of these equipments will not be running. Now, that's also a big opportunity that is lost. So I think we also have to move forward and see what's the future pathway, because these conversations are going to get more and more serious as we move forward. So while we talked about this whole India's transition from BS4 to BS6, and it's a phenomenal achievement the country has done by just bypassing BS4. And that's what we saw from April 1st, 2020. But if you look at the farm equipment, the off-road vehicle equipment, I think from 1st October 2022, we were supposed to, we got the Euro 4 norms for looking at the agricultural machinery. segment. But then within that segment, if you look at tractors, and which is one of the large kind of equipments, then almost, we did some estimate to see that almost 3/4 of these tractors are exempted from the BS4 norms because their engines vary between 19 to 37 kilowatt hours. And that will continue till the BS5 norms comes into effect from 2024. Now we have a segment which is almost consuming the same amount of diesel as buses, roughly 8% of India's diesel consumption in tractors and about 9% in buses. While in buses we have a story that we are moving with flex fuels, we are moving with electrification, but this important piece of equipment, I think, so that's something to be looked at. So I think what we are looking at globally now is this transition towards cleaner powertrains, because especially in urban environment when pollution is becoming a very, very important issue, how do you move toward this cleaner technology, cleaner powertrains? I think that is going to be the future. But having said that, everything will not transition tomorrow. There will be an intermittent phase where we'll use some of the other techniques, some of the other fuels. That's where some of the other technology will come in. But long term, we see that there is a rapid shift going to happen towards zero tailpipe emission vehicles, which can be mostly through electric, but in some cases it could be hydrogen fuel cell as well.
Yeah, thank you very much. I think this is a very unique way you have put like not only the emission control technologies, not only the emission control by switching towards different emission norms, but also focusing on all kind of alternate powertrains, right? Which is being discussed in several other vehicle segments, but not in the off-highway as well as the construction equipment, so tractors and the construction equipment. So I believe we have very unique discussion and it was beneficial for all of you. With this, I will close the discussion and request for any questions if you have.
This is, I mean, really insightful from the eminent panel here. This is Sonal from Curtis Instruments. I mean, I have heard about the engines and their limitations and whatever legislations are coming in. My question is to Dr. Bhalchandra and Mr. Marathe. Where do you see the introduction of hybrid engines in the off-highway segment?
Okay. I will answer in the considering the off-highway is a very big term actually, okay, and it comprises of many different applications. And let me tell you that off-highway may be the one of the segment which is already started the hybrid and the electrification. And I would like to give the example, all the indoor premises operated forklifts nowadays almost 60 to 70% they are moved on the electric. Okay. Second thing is that even the material handling inside the factory, they are already into the domain of electrification segment. Another thing coming, as I said you that, I strongly feel how this transition is going to happen, particularly below 50 horsepower. There is also some specific application, as I mentioned you, excluding the particularly the agri segment. I see that that is the first candidate where the we can say that hybrid or electrification already started and will continue with a larger extent. Then the next will come 50 to 100 horsepower segment. Okay, and anything beyond something 150 to 250 horsepower, still that is the last candidate which is going to fall in this domain, because here particularly in the off-highway, the mild hybrid or the P0 is not going to work, absolutely. Because the duty, the load factor and the duty cycle demands the maximum power. There you need to go at least minimum P1 and onwards, P1, P2 sorts of stages from the hybridization point of view. But yes, already it started for the different application, and then slowly the migration will happen to the rest of the thing. But let me tell you that everyone we are talking about electrification, electrification and electrification. but we need to really think and understand gradle to crave approach also, really in which direction we are. And still we have a sufficient time not to follow east, not to follow west, and decide our own strategy. And I think that in this decade, this is going to happen.
Thank you very much. I think there are a lot of questions.
Just
but
a
we would
single
like
question.
to take up
Sorry. A single question.
One second. We would like to some of them need to move. So we are here, other panel members are here, so we can take up the questions during the break. I'm sorry for that.
Okay.
But we will take up the questions. Thank you very much for your patient hearing, and thank you very much for all your viewpoints. Thank you very much.
Thank you so much.